Okay, welcome to Lab 2, Lines of Charge. So the purpose of this lab is to examine the property of charge using Coulomb's law, to model the transfer of electrons between two charged objects, and to observe the interactions of charged clear tape and determine the excess charge on the tape. Additionally, we are going to model the tape as line charges and find the electric forces of the tapes on each other. Some key physics concepts we're going to use in this lab are Coulomb's law, which gives the force due to two-point charges. We're going to use Newton's second and third laws, which is mass times acceleration, and every force has an equal and opposite reaction. And we're going to use electric field of a thin rod, and that formula is given below. The experiment we're going to do today is floating a piece of charged tape in midair, essentially. And so here in this figure, we see tape B is positioned above tape A. And so the electric force due to tape B on tape A is going to allow tape A to balance out the gravitational force. So here are some constants shown: the length of the tape, the width of the tape, the mass of the tape, and the distance between the tapes. And we're going to use these in our calculations. So in our calculations, we have the force of gravity equal to the electric force. And so basically what this is, again, we're floating the tape in midair, and we're balancing out the electric force and the force of gravity. So I set mass times gravity equal to the electric force due to the line charge, and then we carried out some calculations to get that the charge of the tape is 2.21 times 10 to the negative 8 coulombs. We use GlowScript in this lab to model this interaction, and so I can just walk you through some of this code. Um, Up here, we have the constants defined, and then right here below, we have the function for electric field, which is going to be useful later on. Continuing, we have the line charge function, and this is an essential function for this code because previously, if you remember from the last lab, we modeled this situation using point charges. And so now when we use line charges, we're basically doing like a collection of point charges in a way, um, which better represents the actual situation that's happening. And so in this line charge uh, function, we have a for loop creating a bunch of little point charges. And then at the bottom of this code, we're creating the tapes and setting up our experiment in the model. And then finally, we're going to iterate through each point charge, and we're going to create an electric field for each charge down the line charge. And then this last couple lines of code just represents some general arrows to represent all of the forces. And so this is the output of our model. We're going to balance the gravitational force is the orange arrow with the purple electric field force. And you can see all the green arrows are the magnitudes of the electric forces. Some assumptions we have: do we ignore air resistance? No, the system is static. Do we treat a long tape as though it were a point charge with all the charge concentrated at the center of the long tape? No, we treat it as a line charge. Do we assume that each U-tape you made had about the same charge? Yes. Basically, since we charge the tapes using identical method, we're just going to assume that they have the same charge. A question is, what if you had modeled each of your tapes as a single point charge, like in the previous lab? Basically, because we use the line charge formula, the charge increased. So the point charge from before was 9.79 times 10 to the negative 9 coulombs, and now it's 2.21 times 10 to the negative 8 coulombs. Why do these differ? Basically, the line charge is more likely to be accurate because it takes into account more points on the tape than simply estimating all the charge. In other words, it is better estimate of the integral formula, which gives the exact charge. That's the end of this video. Thank you.